7:00 p.m. Thank you all for joining us tonight for another meeting of the Warren Astronomical Society. I'm Diane Hall, your president for this year, and I'm recovering from surgery right now, so I couldn't be there in person. Our first vice president is in the room at Cranbrook. Jonathan, would you mind having everybody in the room introduce themselves, see if we've got any new members?
All right, well, I'm Jonathan Key, your first vice president.
Jeff, what did I do? How are you? Oh, Carl Outreach, sorry. Oh, Maria Bognac. Sharon Kaplan.
Alan Cap. Brian Levensky. I'm conservative.
Megan. Buddy Spilos. Bruce Super member. Gary Ravello member. Jennifer Dye. Member.
All right.
Got them all, Jonathan?
Yep.
Do we have any new people?
Anybody new? I think we may have new people joining.
Fantastic. How did they find us?
Good addresses and Google Maps.
He said good addresses in Google Maps.
Nice. Well, welcome aboard. Should be a fun meeting tonight. As far as presidential type stuff goes, we've got a treasurer, Mark Miles, stepped forward immediately after our last meeting to be our new treasurer. So we have formally appointed Mark, and we just need to get him on the bank account. So welcome aboard to Mark. We are still looking for a secretary to replace Charlie Strackbine. Anyone interested in becoming a recording secretary, please reach out to the board or to me personally, president@warrenastro.org, board@warrenastro.org. It's not as hard as it used to be because there are digital tools to make the life of the secretary much easier now. So just please, it's actually a good beginner role. If you've thought about getting more involved in the club and you didn't know where to start, recording secretary is a great place to start your career with us. Also, in my field of view for February, I mentioned that we don't have a permanent snack captain. Bob Tremblay was kind enough to bring snacks to the Macomb meeting last month, but it's going to be hit or miss until we get somebody to do it. It's too much for any one person to handle, so especially if they're already pulling board duties. So if anybody is interested in providing snacks for an upcoming meeting, please reach out to the board. You will be reimbursed for your troubles, and everybody will appreciate it. Other than that, we've got an interclub event coming up on the 28th. Our comrades at the Ford Amateur Astronomy Club are doing their annual swap meets, formerly known as the Expo. It's going to be at Henry Ford College from 9 to 3. Henry Ford College is in Dearborn. And it's going to be a full day of programming, swap meet type stuff, good deals on things, camaraderie, the whole 9 yards. So our Mark Kedzier is going to have a table there, and I believe we will be joining him for part of the show. So there will be Warren Astronomical Society comrades there on the scene if you want to attend, but I just highly recommend it. Again, if you've never been to something like that, it's a great introduction to a whole lot of really cool people, since people from the lowbrows come, people from EMU, it's a great scene. Sorry?
No, go ahead.
that concludes my presidential type business. We have 2 items of new business on the agenda tonight that we will need to fit in after the officer reports. And with that, I will pass it over to Jonathan.
All right, for the first vice president, we have a fairly well set calendar. We do have openings this summer, starting in May in Macomb, and so June and July could definitely be some presentations. So if you're interested in the presentation and you haven't done one before, I would be happy to give you a quick run through on sort of my approach. So let me know. And if you have something that you would like to talk about, please see me at the break. That's pretty much it for me.
All right. That was program chair. Over to observatory chair with Riyadh.
Yeah, thank you, Diane. Hello, everyone. Our last open house was February 28th, this last Saturday. Unfortunately, it was cloudy and snowing. However, even with that, we still had about 12 to 15 members and visitors that came out. So we still had a little bit of time to talk about astronomy and telescopes, especially with the new people that showed up, the visitors. While I was there, Mark Mills, our new treasurer, was there as well, and I gave him the $800 from the sale of the Meade 12-inch Cassegrain. And with that, Mark also decided to purchase the Meade 10-inch Schmidt Cassegrain that we had for sale for a year or so now. So that was sold for $500, as well as a small Celestron refractor for $50. So the place is getting cleaned up. I talked to also to Mark Kids here about the table that he's going to have at the Fort Club. So we have a few more scopes that we can sell. Luckily, they're a little bit smaller now and easier maybe to handle. So, of course, because of the weather, we closed the observatory at 7:30. Now our next open house is going to be on Saturday, March 28th, starting at 7 p.m. So let's hope for better skies, better weather for that, and hopefully we'll see everybody out there. Thank you.
Thank you, Riyadh. Good to know that the scopes of Stargate are moving. I don't see Mark on the call tonight. Is he at Cranbrook?
He's here. I'm here.
He's here. Just introduce yourself, Mark, if you would.
I've only met a few of you here, so I'm gonna make this very brief and quick. My name is Mark Miles, and I volunteered to be the treasurer. I've got about 40 years experience in accounting, so I can probably take care of most of what's coming up, I hope. And I'm really looking forward to it. It's a great group of people, and astronomy has interested me my entire life. So I'm here. Thank you very much.
Thank you, Mark. We would normally go to the secretary report, but as I said, we're vacant at the moment. So if you would like to be the one giving the secretary report, contact us. Otherwise, notes are in the WASP. Outreach. Sounded like Mr. McLeod was on the scene at Cranbrook.
All right. Y'all hear me? Uh, Jonathan's on the phone. I think the Belleville event went pretty well from the little reporting that I heard. The Cranbrook event was canceled again. There will be another one. We'll let you know. This one's not next month. It's like their next event is 6 months out or something like that. But I have Night Sky Network pins. There's no rules to this. They're just like, hey, order as many pins as you want. So no one's telling me how to do this. So I just ordered 10 and then I just went through my reports for 2025 and I picked the 10 names that I saw the most. So if you did a bunch of outreach, but you didn't give it to me to put in my reports, you messed up. Uh, so I'm gonna call off some names. Most people aren't here, but I'm just gonna say the names. And this is in alphabetical, not in order of like who done the best. So everyone can argue about who actually deserves the most. Ken Burton, not here. Okay. Maria Borgnar, come up and get your nice guy network outreach pin for 2025. Oh, the moon. Mark Jetzer. Oh yeah. Delores? Here? No? Okay. Ken Lord, not here. Riyad Mahdi, I'll see you in the future. Dave Noble. Man, no one's here today. Let's see. Dale Park. Yeah. Thank you, sir. There's probably a better way to do this. I don't know. Bob Tremblay, I saw you on the internet. I'll email you yours. Tina Long. Here. Okay, hold on. I need to double check that I did all 10. I think we're good. Okay. I got 5 that I gotta hold on to. That's all I got, Diane.
All right, very good. Thank you, Jeff. Um, we on to, sorry, publications. I thought I saw a publication director on the line earlier, but she said she was having a migraine. So I sympathize. The WASP is out, came out on Sunday, right on time. So if you are interested in contributing to the WASP, email publications@warrenastro.org. Other than that, I think that's it for the officer reports. We can move on to subgroups. Anybody got anything going on with the sun? We've seen the sun lately, occasionally.
Oh, we got a hand up, Tom Hagan?
That's when we had the first spotless days since 22.
So last week we had the first spotless day since 2022,
Wow.
and then 3 in a row, Rik Hill says.
All right. So the sun is getting quiet. Well, that's we're going to be entering the boring times. Um Over to Riyadh for the double star group.
I have not.
Yeah, as usual, we're going to have a list next open house of the double stars for this time of the year, and hopefully we'll be looking for them. In addition to that, don't forget we're going to be looking at Tau Corona Borealis and see if that star is going to have its show. It's a
Nice.
couple of years late now, so
Nice.
we'll look at that.
Fingers crossed. Radio subgroup with Tom Hagen.
Well, I'm still looking for interested people. I'm not sure how we can get together. Maybe we could set up a Discord or something on the Facebook page or okay. Yeah, maybe I can get started on that. I'm sorry, what? Oh, okay. Yeah, let's talk about it after the break or something. Riyadh and I have been talking very little bit about setting up what's called a radio Joe setup at the observatory. This would be a, a radio monitoring setup that would monitor 24/7 for emissions from Jupiter. The problem is that the antennas are dipoles and they're about 23 feet long, so that's not going to work out there too well, we think. But there may be a way to get a much smaller, what's called a loop magnetic antenna to work. So I'm working on that right now at home. It's not running yet, but it's coming along. I'm also involved with a data analysis project for radio radio astronomy data that comes off of a 12 antenna low frequency array, and this is very preliminary. It would be is anybody familiar with the Galaxy Zoo? Or this the idea came from there, and it would involve making data plots available for the public to look for anomalies and things like maybe fast radio bursts. If we were actually to detect a fast radio burst from the system, it'd be the first one in history. So do that. That might be kind of fun. So more on that later. Thanks.
All right. Thank you, Tom. Anybody wishing to lead one of our former subgroups or be officially the solar subgroup captain or to resurrect the urban astronomy group or other groups, let us know. There's always room for more astronomy. And with that, we can kick things over to observing reports. Jonathan, you're at the mic, and I believe you've got one.
Oh dear. Uh, oh yeah. So as Jeff alluded to, Adrian, Bradley, and I did a public astronomy event at the Belleville District Media Center, which is actually quite a ways from sort of downtown Belleville. And the skies would be really nice there if not for the fact that it's next to a police station and it has a bunch of extremely bright spotlights around it. But we had a great time despite the fact that there were clouds. We were observing the conjunction of Jupiter and the moon, and the moon poked through the clouds easily, and eventually Jupiter joined it. And it was a really cool arrangement because the moon and Jupiter were on one side of a giant rectangle, and Castor and Pollux were on the other side. So there was this beautiful rectangle of celestial objects up there. And it was really cool to see. Later in the night, when more clouds cleared out, we showed people various objects, including the Orion Nebula. Unfortunately, we never got to show people the Beehive cluster, which is my favorite object. A little bit big for most telescopes anyway. And Adrian used C-Star electronic telescope to do some live imaging of the Flame Nebula and the Horsehead Nebula in Orion. So that was pretty cool. But it was a great event. We had about 30 people out, and it was lots of fun. And they've invited us back to do solar observing this summer and then a fall event as well.
Jonathan,
Yeah.
are you having any feedback with the mic there at Cranbrook? Because the sound is going in and out like a sine wave.
Oh dear, not here, but it might be just the microphone on this laptop. Maybe we need an external camera.
Okay. Yeah, because I noticed it with you just now, and I noticed it with Tom when he was talking. So it's just going up and down and up and down.
I wonder if it's noise canceling because it thinks it's getting feedback.
That could be. That makes sense. Anyway, just wanted to let y'all know. Do we have other observing reports? Jonathan, anybody there on the scene at Cranbrook?
Very morning. would you like to come up or?
This is from the beginning of actually from the end of January. I posted this on the Facebook page of Warren Astro and on my Facebook page. I noticed on the third interstellar meteor, there's two recognized by the IAU, and this was reported by the NASA JPL. Has a page which reports the findings of the Space Force, government satellites that are monitoring the world, and they saw a fireball, and the speed of this was 71.1 kilometers per second, which is faster than the two previous interstellar meteors. So this is a hyperbolic trajectory, means it came from outside the solar system. It's from way out, and it's quite an interesting event. Thank you.
Thank you. Anybody else there at Cranbrook with an observing report?
Parker, would you like to come up? Okay, I'll have to repeat it. Okay. Was in Spanish I picked that up and made it break in I cluster and NGC and I know in 1981. Very cool. They were very nice, formulating the decided so for those on the call, Parker got the 10-inch job that was, I think, advertised in the last WASP, and he broke it in with the Beehive cluster and with NGC 1981, which is a
Nice.
particular favorite of mine.
Good deal. All right. Do we have any observing reports from the crowd online?
We actually have an observing and astrophotography report from Maria.
Very good.
I don't know, is it?
No, that's not showing up at all. Okay.
Oh. That's the moon. It's the moon.
Wow.
Can't really focus there. If you want to send it, if you want to email it, I think it can't focus there. So. It looks better in person. If you want to send it, just email it to firstvp@warrenastro.org.
Okay.
Then I can just project it.
And before we progress to new and old business, I see our publications director is back online. Anything to report for publications?
Sorry, I had to find my unmute thing here. New WASP is online, so if anyone missed out on their newsletter, check the WASP website and grab it.
Very good. Thank you. Okay. If that concludes our observing reports, and I'm looking for hands, I don't see any hands. Bob Tremblay, do you want to talk about the lunar eclipse such as it is?
Well, it starts tonight at like 3 a.m. and totality starts at 6 a.m., which I'm not really sure, but that should be starting to get light then, which is annoying. And totality ends at around 7 something. I don't know what it is, but an hour or so later, and it will be light then. So it might make for some interesting pictures. I don't know. You might have some blue sky with some red moon, but so if it's clear, go out. It starts at 3 a.m., so it will be dark when it starts.
All right. Thank you, Bob. We've got two pieces of business to conduct before we have our short talk. I see Rik Hill, our guest, is on deck. Number one, in January, or actually last December, we talked about a revision to the bylaws. We have not yet voted on that revision. So, Jeff McLeod, are you in a position to come reread briefly your proposed change to the bylaws so that everybody knows what they're about and we will vote on the next Cranbrook meeting in April.
This is the secretary's job. Do you have where I don't have it pulled up.
All right, I can read it.
Okay. I was not informed. I'll just pantomime like I'm saying it.
All right. Written amendment has been submitted by Jeff McLeod. WASP bylaw amendment. Article 7, Financial Procedures and Restrictions on Transactions. Section 7.05, the compensation of employees. The directors of the corporation shall serve without salary, but the board may authorize the payment of reasonable expenses incurred by the directors in the performance of their duties and reasonable compensation for special services rendered by any director. Except as provided in this section, no officer or trustee of the corporation shall receive directly or indirectly any salary or other compensation from the corporation. So that just means board members don't get paid by the club. However, the revision would be section 7.05A, waiving of director membership fees. This is the new language. In recognition of the time, effort, and services rendered by members of the board of directors in carrying out the purposes of the corporation shall waive the annual membership dues for each director during their term of office. The waiver shall be considered a form of reasonable non-monetary compensation for services rendered, consistent with section 2.02 of these bylaws and applicable provisions of section 501c3 of the Internal Revenue Code. Such waivers shall not affect any other rights or privileges of membership, and directors shall be considered members in good standing for all purposes of these bylaws. So, we will be voting on this at the next Cranbrook meeting in April. Any questions?
Nope.
All right, before we have our short talk, I have one great new piece of business to announce. As you may know, we sponsor a scholarship, the Paul Strong Memorial Scholarship at Macomb Community College. We just received notice of the awardee for this year, Kayla Boitnut, who is receiving the $250 scholarship to make her career as a future science-oriented graduate better. So, round of applause for Kayla, and it's always good to see that our work is continuing down the line. So, if you want to donate specifically to the Paul Strong Scholarship, see our treasurer. With that, I will hand things over to Jonathan to do his duties as first VP.
All right. Well, our first short presenter tonight is not particularly short. You may know him as the Cowboy. You may know him as that guy who drives a Gemini spaceship around towing behind his truck. But those of you who do not know him as well know him as Jeff McLeod, and he will be telling us about measuring the distance to the moon the old-fashioned way. Jeff, come up and take it away.
Try to project, Jeff, because we're still having the sound dips.
Oh no. I'll project so that I'll be loud through the.
Well, you have to be loud here too.
Oh boy. My notes. while this gets set up. So in researching this topic, Jonathan, I don't know what happened. He may have psyoped me a little bit. He just said, "Hey, when your presentation in March, like, what do you is the give me the picture and the bio." And I go, "I scheduled a presentation in March," and he just told me it was my measuring the moon. I go, "Okay, I guess I did I say that?" I think he knew that there was a lunar eclipse or something. Uh, but I dig back through my notes and I go, "Oh, it's going to be the 10-year anniversary of when I gave this talk." No, it's like 11 years ago, and the eclipse was 12 years ago. Oh, how the time has flown. So some of you have heard this. You've probably forgotten. I know I did. Um, did we fix everything?
I hope so.
Okay. If it's not fixed, don't say anything. Okay, it works. Oh, that.
Oh, yeah, I guess that would help, wouldn't it?
So, when I first gave this talk, I had been a member for less than 2 years. I was newly the secretary of the club. I hadn't gone back to school. I rode a unicycle on the stage. A lot has changed. At the end of the presentation, I said I was more comfortable on the unicycle than I was behind the podium. That's reversed now. I'm more comfortable here than I'm on the unicycle. I'm officially, legally over the hill. So this was a presentation I made before I was a jaded over the hill amateur astronomer. So basically, I was a youngish man, talked to Dale Parton. He was doing really cool ancient experiments. I'm pretty sure we talked about this one, and I'm like, okay, I'm gonna do this. I was working at the time. A lunar eclipse was coming up. I took the next day off because I knew I wanted to be up all night. And this was April 15th, 2014. Okay. Huge snowstorm is just ripping across Michigan. So I'm like, okay, I'm just gonna hop in my car and start driving west, and I'll get in front. The storm is moving east. I'll move west, no problem. So I just get on, I think 94, and just keep driving, and it doesn't clear, and I just keep driving, and it's still not clear. And eventually, I call my buddy in Wisconsin, and I'm like, "Can you pull up like the weather? Am I just driving for no reason? I know it looks like it's gonna clear." The eclipse starts at 12:30 at night or something like that, or just about 1 in the morning. Uh, I'm into Indiana. Okay. I'm like it's starting in like 10 minutes. Finally, the clouds break. Uh-oh, is it still not working? The clouds break. Can they at least hear me or no? Yeah. Or
You're fading in and out, Jeff.
I'm fading in and out. Okay, hold on. I'll do this in the exact opposite oscillation.
Can you turn
It'll
voice cancellation off on Zoom?
It is turned off. Everything is turned off. Yes,
Yeah.
you can, but people on the Zoom and the YouTube cannot.
It's not me moving. This is something else. Yeah, I'm
It's
good
not.
with that.
This microphone is the microphone to worry about.
If I get really close, you're gonna see my face like that.
Now you sound clearer.
Is that what? Should I just do that?
You could.
I can put my ego aside and just have my face blown up on the internet.
You know, it works for some people.
If you want to see me better prepared and better looking, go on YouTube and find this presentation from 2015. There's less problems. So, where was I? I'm in Indiana.
Indiana.
I pull off the highway. I find some church, and I just start unloading equipment, setting up my telescope. Uh, uh-oh, now this doesn't work because he's doing stuff. We'll wait.
No, go.
I'm happy to say that my astrophotography skills have not gotten any better in 10 years. This was the best picture of the moon I got that night, and that's about as good as you're going to see from me forever. Uh, but I wasn't there to take pictures. I was there to take measurements. But on the way, I'm driving through this snowstorm, and my car is developing a coating, probably several 100 pounds of ice on my car at some point. Almost crashed twice, just kept driving, uh, for better or worse. Uh, After the eclipse, I'm in Indiana. I'm a hop, skip, and a jump from Yerkes Observatory, so I might as well just drive north. I call Yerkes. They open at some time. I have a buddy who lives right on the border of Wisconsin. He's like 10 minutes from Yerkes. So, hey, let's go to Yerkes. Uh, he was a dairy farmer, is no longer, but got to meet the cows. So you use astronomy as an excuse to go and see other things. So I'm driving past Chicago. I might as well go to the tower, and at the time I'm doing handstands and stuff. So that's me in the skybox type thing. So these are my notes from the eclipse. This is what real science, if Gary Ross were here, real science, this is what it looks like. It's the back of an envelope. I'm just writing down the times where the moon is. I barely know what I'm doing. I have a vague understanding of what I'm trying to accomplish. Uh, Maybe I should give some background, or maybe we'll just keep going. So there is a way that we're going to explain that you can determine the distance to the moon using a lunar eclipse. There are ratios to exploit here. I was going to open the talk with how far away is the moon, class? 240,000? Yes? How do you know?
One lunar unit. I read it.
Yeah, read it in a book. Okay, he can say that. Yeah, you can measure it. And that's not lying to you. Everyone else could be lying to you. So the first timing starts when the moon hits the Earth's umbral shadow. Okay, that's like the one that you can really see. There's the like if you ever see an ad for a penumbral lunar eclipse, don't go. They're not worth watching. You can't tell anything's happening unless you have like a light meter. So the moon touches the shadow. That's the start of the eclipse. We start our timing. When the moon is completely into the shadow, that is the time it takes for the moon to traverse its own distance. Okay? And then when the moon leaves the shadow completely, that is the time it takes for the moon to traverse the shadow of the Earth. Okay? And the ratio between those is what we're looking at. Scribble scratch. Again, this was before I went back to college, so this was like, oh my God, how do percentages work? Yeah, it's not my best word. In the like, there's a perfect parabolic arc of my math where no math, all math. I'm back in my like, math. Jeez. Pay me and I'll do some math. So I have my numbers, but I'm trying to replicate an ancient experiment. They didn't use the clock on the dash of a Ford Taurus. They had something less sophisticated than that. So after a lot of like research and thinking about like what am I actually capable of building, I settle on a water stopwatch, not necessarily a clock. But how this machine works is there is a main tank, a distribution tank, my overflow tank, and the actual measurement down at the bottom. So I'm gonna try, oh, I have a pointer, okay. So water is gonna come out of the tank into this bottle here. There is a pipe It comes out into the overflow. That keeps the level of the water the same as the clock is running. So we don't have changes in water pressure. Okay. And then there is water flowing out of the bottom of this. If I go to the next slide, so you can see water going out of the overflow, water coming out of the bottle. I don't want a lot of water. I want a manageable amount of water because this thing has to run for like a couple hours. So as this is going, I'm constantly taking water out of the overflow back into the main tank. It goes into the distribution tank, back into the overflow, back up and around. Now, obviously, plastic bottles and hoses and tubes, yeah, they didn't have that in ancient times, but you could, in theory, build something equivalent with ancient techniques. However, I now have my timing of the time it takes the moon to traverse its own diameter and the time to traverse the Earth's shadow in volumes of water. So I need to compare those. So I build a very rudimentary but very accurate balance beam. These look like they're on the ground. They are actually ever so slightly floating above the surface. And so now I can take a ratio between the heavier one, which is the moon traveling the Earth's shadow, and the lighter one, the moon traveling its own diameter. However, these buckets also weigh something. So I need to compare an empty bucket to one of those buckets. This gives me a unit of measure in empty buckets. I believe it's better than the kilogram. Uh, Although it's really only good for this one measurement. So now I have ratios that I can compare. None of the numbers really matter. It's all ratios, okay? So I end up getting a ratio between the moon's diameter and the diameter of the Earth's shadow of 2.3 to 1, okay? But I need to know something about the Earth's shadow. So there's some we're going to make an assumption that shadows on Earth are the same for the Earth's shadow, which is a pretty safe assumption. So this brings us to the eclipse machine. How long is the Earth's shadow, right? So you put a bowling ball on top of a rod, you wait for the sun to be pretty low in the horizon, and you measure the ratio of the shadow. So this is where I attach a string. We pull the string. I have a board in a box, and we'll get a closer view. So the shadow is going to come into this hole in the front. Oh, I have labels for this stuff. So I have a peep window up top here. I can bring my arm in, and then I can draw on this sheet of paper. I have two nails at the top that are perpendicular to the board. So I'm shimmying the board until the shadow of those nails disappear. And that means the board is perpendicular to the sun. I get a nice flat shadow. Somewhere, yeah. So here's a picture of the shadow onto the board. This is a picture of me making marks on the board. And so here's a photocopy of, whoops, oh boy, what did I do? I turned it off. Oh. How did I do that? Okay. Spooky. So for measurements, average it out, I get a ratio of 109 to 1. So the length of Earth's shadow is 109 times longer than the diameter of Earth. Okay? And another thing I wanted to mention, if you find any of these numbers suspicious, just double check me. Go build the thing and tell me that I'm wrong. I would really appreciate someone doing that. Besides you. You've already done it. You don't have to do it again. So here's the Earth. I actually used Dr. Parton's number for the diameter of the Earth because you need to know that before setting out, but that's another difficult thing to do. So I take that, I multiply it by 109.3, I get this number here. That gives me an angle. Don't worry about the math. This math is actually wrong. All you have to do, this 3.31, that's that ratio, 2.3 plus the moon. That's C here, B plus A, right? B was 3.21A, so 3.31. The way that these, uh-oh, these are similar triangles. This whole system works because the angular size of the moon is very close to the angular size of the sun in the sky, which means that this angle here is the same as this angle here. Okay. All you have to do is take big C, divide it by little c, you get your number. I got 250,000 miles. I'm just going to tell you right now, I'm right for the wrong reasons.
Wow, what a tradition.
Yeah. Sometimes your errors compound in your favor. Um, I don't know where they are. I just know that they are. Okay. I've done this again with other eclipses, and sometimes almost bang on. Other times, not wildly off, but like 15, 20% off. Okay. And this is because this is assuming that the Earth is passing dead straight through the middle of the shadow. If it posts above the top,
The moon.
the moon, oh, sorry, uh, the moon going into the Earth's shadow. If it's a glancing blow, now you on the ground, it's really hard for you to keep track of like the incoming and exit angles. Yes,
Also, the distance to the moon is variable because the Earth's moon's orbit is elliptic.
correct. Sometimes it's closer, sometimes it's farther. I think when I I tried to get a good estimate of exactly where the moon was to compare this, and it was like 5%. Um, But yeah, this eclipse, it didn't pass dead straight through the Earth's shadow. So it really shouldn't have been this good. The idea is you do this for every lunar eclipse in a century and you average those values out. Um, and I've done it for a couple of them, but for some reason I never compiled that data. Um, so I didn't change this presentation from the original at all. These were the future plans back then. Thank God the future is still out in front of us because I haven't done any of these. Um, I can't figure out a way to determine the size of the Earth without cheating. It involves biking like 60 miles. I'm not here for it. I can't bring myself to do it. Driving's cheating.
Oh,
Well, also, if you're driving, how are you keeping track of your distance? Yeah, but you're doing all of this on the highway. So how are you getting a decently accurate, like how far north south did I go?
you're gonna have to figure out your position by the stars every night.
Yeah, I'm not doing it. Uh, I I believe there's a way if you find a moderately tall thing that you can climb, and I can climb rather fast, with some like good flat like lake horizon out in front of you. So west coast of Michigan, somewhere that has a 30-meter tower or something, you can huddle at the bottom with a stopwatch, wait for the sun to set, start your timer, climb up the pole, and then wait for the sun to set again. Stop your timer, you know the height. You can get a really rough estimate that way, and that would be easier. So maybe someday. This other stuff, it's not happening. Uh, that's all I've got. Questions?
Who did this first?
Well, oh,
I mean,
Dale?
um, I remember.
Eratosthenes did the size of the Earth. I don't know who did this.
It might have been a guy named Aristarchus, but I could be wrong.
Oh, Eric, yeah, that sounds very familiar. Yes, we're gonna go with that until proven otherwise. What he said, Aristarchus. Yeah, that sounds really familiar. Sure.
Lunar crater name there. Hipparchus.
Who doesn't have a crater?
Hipparchus.
Hipparchus?
Hipparchus.
He's back there. Anyway, any other questions? I'm gonna get out of here.
I have a question.
Uh-oh, yes.
What other examples of errors adding up to in your favor can you think of?
So many. So I part of my notes was just like crunching the numbers based on what I measured from the clock, without the water clock, like just my clock, and using the actual like length of the shadow that I just like Googled, which is rounded to the nearest thousand, so it's not actually very good. But I get 262,000 miles, so a little bit further out. But who's seen a lunar eclipse? Okay, almost all of us. So how sure are you it's started? Right? There's like a minute in there where you're like, and then 2 minutes in, you're like, oh yeah, there it is, there it is. And so there's errors in when exactly does it start, stop. So like I tried to take the start when it's in the middle, when it's at the end, and you can also get like an in and out, like kind of double measurement of like how long it takes to traverse its own diameter, and so you can kind of average those. But again, the eclipse isn't perfect. It's like rolling in over the top of the shadow. And so it's like sometimes there's an area that's always like very bright and it really gets like hard to know exactly when things are starting and stopping. The whole measurement of the water is like, I mean, I was like pouring it through coffee filters because I got this tiny hole and it would run for an hour and then it would stop for 30 seconds and then it would start up again because a tiny grain of sand got in there. The balance beam is actually pretty darn good. But that shadow, the shadow has an umbral and penumbral like all shadows do, but like so you're trying to measure the width of this fuzzy amorphous blob, right? Um, so there's, and this again, before I went back to school, my significant figures are horrific. I have no business taking this to three significant figures. I'm just doing it. Uh, yes,
Greeks have even worse, because they do not have decimal.
yeah. Oh, I can't imagine doing this in their horrible math system with no zero and also like when they did this, they had to like go to a mason and say like, hey, will you construct a spherical ball for us to like measure? Which artisans could certainly do, you know, 2, 3, 5,000 years ago. Um, but also like the string measurements and stuff, like someone had to like handcraft those kind of things. I used a tape measure when I was measuring my valence beam, but I did think like, oh, well, I could get a string and wrap it around and count the coils. And then I'm like, okay, well, if I can do it, I'm not going to do it. But as long as there's a way for some ancient person to have done this, I feel like it counts. But yeah, there's errors everywhere, just everywhere, which is why you need multiple people doing this, multiple eclipses, and then it really gives me an appreciation for how much we actually did figure out as far back as we had it figured out. Like Newton knew that the moon was like slowing down and speeding up. Like, guys, for you to make the observations to determine that the moon is slowing down and speeding up as it's going around the Earth is like phenomenal with the even the technology we have today that's difficult to do. Who has the time?
7:54.
All right, short break, snack break. Yes.
Indeed. Thank you, Jeff, and we'll be back in 20 minutes at 8:15.
Not 20 minutes. I think 10 minutes.
10 minutes? Okay. 8:15 was what we put out in the email.
Oh,
8:05, that's fine.
all right.
8:05.
Is the sound on the laptop's microphone better now?
Yeah, it was
So it
much
just
better
has
during
to
this
be it
presentation.
has to be straight in front of us, which I guess is a more flattering angle too. So good to know for the future. Hello. Well, that would be awesome if I mean, you, you have a lot on your plate, but i- if you feel like it, that would be awesome. And we have cups and plates, so we can start bringing them at least until we run out. Actually, Bob Tremblay has a bunch of cups and plates, and then Diane and I have a bunch of cups and plates. Yes, yes, yes. I'm not going to be. We're going to be in Puerto Rico, but we can definitely plan on that if you're up for it. But the WASP will be meeting that night. Why don't I see you in the microphone? Rick, would you want to come back on camera and just double check that everything is still good? Yes, sir. Excellent. Would you want to maybe do it together? That we made them? It's May the 4th. We'll have to have a okay, so we'll bring it back to April. Okay, you're up for April. All right, I will let the board know. Yes, Cranford. Okay, sounds good. Yeah. All right, excellent. Thank you. Go. I'm going to get a beverage. Sorry. More action on this side. But in mind, having starting action to the response. Yes. Yeah. You think that over and they're also the same as in the top. Okay, transfers.
Thank you very much. I'm just here to hear your brother. This measure is okay. Well, whatever. Yeah, I should talk. Oh, yeah, no, it's lost. In one of the bag. It doesn't play. Yeah. Also, I know do you know this? You were thinking that's a different issue.
Rick, are you able to turn your video and audio back on? All right, we hear you, Rick.
Yes, now you should see me too.
All right, excellent.
Yep, we see you.
All right. And Rick, do you know how long your presentation is about?
We'll see how long the connections holds up.
Okay.
Now,
But like,
I've been getting warnings from my Cox highest speed internet that I'm overloading things. And so
oh no.
if I get that during my talk, I'm going to turn off the picture, but I'll keep talking.
Okay, sounds good.
All right, so we've hit 8:05, so Jonathan, over to you for
All
the
right.
introduction.
Sorry, give me a second to pull up my notes here. All right, we're about to get started. Our main presenter tonight is Rik Hill. Uh, he was born in 1949, shortly after Antares was obscured by a nearly full moon. His first astronomical observation took place on May the 6th, 1957, during a Mercury transit. Rik got involved with the Association of Lunar and Planetary Observers and founded the solar section there, and the American Association of Variable Star Observers. He co-founded the Sunset Astronomical Society in Midland with his wife Delores. He worked at Kitt Peak for 12 years, uh, worked on Kitt Peak at 12 years, and worked on the Catalina Sky Survey and discovered thousands of asteroids and 27 comets before retiring in October 2015. Now he focuses on astronomy from his home observatory while caring for bonsai trees and fostering rescue cats. Uh, Thank you, Rik, for joining us from Arizona, and take it away.
All right. I assume you can hear me fine.
Very well.
Good. So what we're going to talk about here is I'm going to
We
have
got
to take my
feedback.
earphones off.
Yeah,
Yeah,
we got
that's right. I'm not sure why you've got feedback or why I froze.
Now we can hear you fine.
Everything. Oh, good. Okay, fine. What we're going to talk about here are techniques and tools for lunar imaging. I've been doing lunar imaging ever since I started in astronomy. I did observe an elementary school substitute teacher at Green Elementary School over in West Bloomfield. And that started me off on this. And the moon was, of course, an early and easy target. Let's go to the next slide. I have no control of the slides. There we go. One of the reasons why the moon, not only is it easy to get to, but it's the only place where you can actually directly image topographic features. There's no other object in the solar system. Mars comes close, but falls short. So next slide. Okay, that's fine. Like I said, there's no go-to needed. If you can't find the moon, you probably ought to think of another hobby. It's the closest natural object to us as well. Next. We'll get a rhythm going here. Don't worry. And why the moon? Well, there's a reason why. 5 space programs are going to the moon very soon. China, though they haven't been very active lately. Russia, Japan, India. India's been very active in it, and the ESA has been reasonably active. And the thing is, they're all going to be digging holes when they get to the moon. The reason why is once you get there, if you're going to make any instruments or anything, you've got to mine your materials right there on the moon. And so just like in the movie Moon, they're going to be mining on the moon and digging very large holes, kilometers in size. And so if you want to be able to see these from your backyard, you got to hone your skills now. Next. good quality imaging can be cheap and easy to do, but you got to practice. You got to. It's like anything else. You don't want to start practicing at the moment it happens. Next. That's everything all at once. Next. There we go. Now I want to warn you about this. When downloading freeware, and I will be recommending a lot of freeware here, always be very careful before you click the download button. Make sure you're downloading exactly what you think you're downloading, and that you have nothing else attached to it. It's very dangerous because you can and I have gotten pirate software, and you don't want that in your computer. It just ruins your whole day. Next. Now, the first thing you want when you get started is the Virtual Moon Atlas. This is a piece of freeware, and this is where you should get it from, nowhere else. And it's made in France, France or French Canada. I think it's France. And it's a very good piece of software. Next. This shows what it looks like when you open it up. When you open it up, you get the whole moon over there for the image. But a few clicks when you zoom at the very top, and you can go down to something like this, which is the same image we're using for the background image here in this talk. And you get quite a bit of data on the side about what the phase and the colongitude and everything is. And this comes in handy if you ever want to repeat this observation for the same lighting conditions. That's right there is the same thing we were just looking at in Virtual Moon Atlas. This image right here is done with a 14-inch, but you can see this much detail in a good 8-inch telescope on a good night. You got to have good skies. Then it also gives you a lot of other information right here. Like I said, colongitude, phase, libration, illumination. All of that's important as you get to know more about observing the moon, and especially if you want to repeat the observations. You can see up there that it gives you distance too in kilometers, so you won't have to compute it yourself. Next. And it gives you some other information on a specific object. If you clicked on the crater Huygens there, or Hyginus, if you click on that, it tells you it's 10 kilometers across, and the walls have a height of 800 meters, and it gives you a lot of other information about it. This is really handy. At the very bottom, it tells you which Ruckel map you can find it on. The Ruckel maps are just fabulous. Next. Now, another one to get started with, and you should spend a couple evenings doing this. This is real easy to waste a lot of time on this, and that's the LROC Quick Map. Next. It's from the Lunar Reconnaissance Orbiter, which is run out of Arizona State University. Here's an image from the LROC Atlas, and you're seeing down to about, in that previous image, you're seeing down to about 1 kilometer, maybe a little better resolution here. Next. And you can keep going down, and you can go down much further than this too. And it's incredible the amount of detail. You won't see more than what's on the LROC. It's just not possible. And it goes down to literally objects that are just a meter across. Next. The Full Moon Atlas is nice. I don't use it nearly as much. And you might enjoy that one, the Full Moon Atlas. Next. Here's a picture of the opening page in the Full Moon Atlas where you can select what section you want to see. Next. And here's the map of the same area we're looking at for the background image and that we were looking at with the Virtual Moon Atlas. It's the Huygens region, and this big crater down there just is Treisnecker, very famous for all the rills all around it. In this one view, you have an example of all three rill forming processes here in action. You've got a graben over to the right of center. You've got the Huygens rill, which is in the middle there, which is formed from volcanic venting. And then you got the Treisnecker rills, which are formed from other tectonic activity. Next. Now, what telescope to use? What's the best telescope? Use what you got. If all you got's a Questar, that's fine. You'll see some great Questar pictures in here. You just tailor your observing for what the instrument you have. I've got a 4-inch right behind me here, 4-inch Celestron I stuck on a German equatorial mount. It's an excellent instrument, and I can take great pictures with that. And I can image down to about 2.5 kilometers on the moon. 2.5 kilometers you can see by looking out your front door. That's not a long distance. Also, we'll discuss accessories like filters and Barlows. Those are important. And it's always a fight between aperture versus average seeing. And I'll show you a bit of that here. Next. Okay, these are some examples of cameras. I use the SkyRis cameras. I just like them. It's in the upper left. I use them, and the next image, which is in the low, center bottom. I started with the camera that's down in the lower right, image source camera, and I have a QHY, but I haven't used it much. So whatever camera you can get, if all you've got is an old trying to remember the name of it because it's been so many years since I used one. But if you've got an old camera, even a dash cam you can use, but it won't work very well. Next. And phones, a lot of people are using phones now, and those cameras don't do well unless you're willing to go through a lot of gymnastics to expand the image and get a good scale image going in your cell phone. These are Barlows, various Barlows. You will be using one. They're an important attachment for your telescope. Spend a little money on the Barlow. Get a good one. Don't get a cheap one. The Meade ones are not bad, but the Teleview is a much better one. Next. Filters. Get yourself a good selection of filters, but especially the filters you see over on the right, the red and orange filters. Those will help you with your sky conditions more than any others. The other filters you'll use when you get a little more sophisticated in your lunar observing and you want to look for various areas of metal outcrops like potassium or calcium areas. But for just taking pictures, just use the red filters. Next. So what are you going to see? Okay, you see aperture in inches going down the left side, the left column, and that goes from 3 to 14 inches aperture. And then you see over here, well, they got it in millimeters too. And then you see perigee and apogee. The moon moves, you can see at the bottom, its distance varies by quite a bit. And it makes a difference in what you're looking at the moon. For the average 8-inch, which is right in the middle there, you can see that at perigee, you can see 1 kilometer on the moon. At apogee, it's 1.1 kilometers. And there are a number of objects you'll find that will show you the difference between those at the different perigee and apogee, different distances. I use an 8-inch. An 8-inch F20 Moxitov Cassegrain. F20 will become important here in a minute. Next. Now this is my Questar set up for observing, and I've adapted some medical instruments to be slow motion on the RA deck. They give me about a 10-to-1 slow motion, which is very, very handy when you're moving around on the moon. And then you can see my very fancy autofocus there, a wooden clothespin. Use what you got, like I told you. But those things work very well. And that's that first camera I had, and I can't remember the name of them. Isn't that terrible? But that was the first digital camera I used. Next. This is a picture with the SkyRis camera, and it's the moon near full, and we're looking down here at you can see let's see, what do we got there? Wargenton, we've got Wargenton's the crater. You see three craters down there in the lower middle there. The middle one is Wargenton, which is an interesting crater because it's one that filled up with lava and then that solidified. So the crater is actually just a gigantic plateau. Very interesting to look at. And then you can see the dark spots in the bottoms of craters, the dark patches. And these are areas of different metallicities and different flooding from different impacts. And you'll be able to image all this. And this is just with a 3.5-inch telescope. It'll do a fine job. Next. This is with the same Questar. Everybody knows the three craters in the center of the moon there. Alphonsus is the middle one with the mountains going down the middle. And then Alpetrogeus is next to it there. And then Ptolemais is above it, the big flat walled plain, they always called it when I was a kid growing up. These are you're seeing a lot of detail in these craters too with a 3.5-inch telescope, like I told you. I'm using a SPC camera, which was the image source camera, and it did a fine job, but the pixels were large. There were 15 micron pixels in that camera. So this was about the best I could do with it on a Questar. Next, please. This is my 8-inch. It's f/20, and I use it on a German mount. I like German mounts better. And this will take me down to 0.9 kilometer craters. Next, please. Now, important things that you're going to need besides slow motion, you can see on the picture on the left, I've got a test tube holder on the micrometer focus of the telescope. This gives me wonderful slow motion control of the focus. And I've used this for years now. And you'll need that because you've got to get the focus exactly right. This has got a SkyRis camera mounted on it. It's not necessary, but I find that the right angle interface between the camera and the telescope, where you can flip the mirror in and out, that's very handy. But usually I move around on the moon just fine with using the camera. Next, please. So you need to determine what's your best seeing. Is it early in the night? Is it the middle of the night? Or maybe it's early in the morning. Mine is right after sunset. I get my best seeing. And it's because you get much into the night and you get the cool winds blowing off the mountains here in the desert. And that's a real problem. And some nights I can just be out there and see, because I live near the mountains. I live in the Rincon Mountain foothills. And the cool air will come sliding off the mountain about 2 hours after sunset. And you could just see the image fall apart and start to boil. Heat elimination may be something that's a practical thing for you to do. At my old house, when I had one of those metal shed observatories, I had sprinkler hoses wound on the roof of the observatory. And I would just turn the sprinkler hoses on for a few minutes before I started an observing session to wash the heat off that building from the day. We get a lot of heat here in the desert. 120 in the summer is not unusual. In fact, today was 92. So we had essentially no winter this year. We never had frost. Next. Webcams are best. CCDs are good. They're a little more gymnastics to use a CCD because you'll have to do darks and flats and things like that. CCD or CMOS, like I say, CMOS cameras are the popular ones now. That's what the SkyRis is. And they work perfectly fine. Phone cams, well, when I wrote this originally 10 years ago, phone cams were not that good. Today they're getting better. And today they built mounts so you can actually put the mount on your telescope and it'll hold the camera nice and still. But still, you have to blow the image up enough to get, this kind of like in the background image, to get that kind of detail. You're going to have to blow the image off a lot. And I haven't had that much success. But at Halloween, when we show the sky to kids and their families when they come by, we frequently have them show them how they can take their cell phone, put it up to the eyepiece, and take a picture of Venus or Jupiter or something like that. And they go away thrilled that they even got a picture. So dash cams are no good. But if you've got, some special event like a lunar eclipse coming and you have nothing else, use a dash cam. Next, please. This shows why color is not as good as monochromatic. You're better off getting a monochromatic camera for lunar imaging. And that's because every picture element consists of 3 colors with a color camera. Well, that reduces your resolution by a factor of 3. And you can turn a color camera into monochromatic with the software, but it doesn't work as well. So I highly recommend if you're going to buy a camera, you get a monochromatic one. And I like the SkyRes cameras Celestron was making. I'm sorry they stopped making them. But you're also going to want a camera where the pixel size, you're looking at pixels there on the right, where the pixel size is going to be around 7 microns. If you have 7 microns, and you take your camera out like you've got an F10 Schmidt Cassegrain, use a 2x Barlow so you're working at F20, you'll be working at what's called Nyquist sampling. That means you'll be working at the maximum resolution of your telescope. So the only thing you're going to be dependent upon is the seeing. And if the seeing steadies out and you get really good skies, you'll be seeing everything that's capable of your telescope to see. And that's important. You need that Nyquist sampling. So you want to be F20 with 7 micron pixels or smaller. Now, the next image cameras have 5 micron pixels. So you could probably just use F10 and get away fine with that. But if you've got 15 micron pixels, you're going to want to be F20, maybe even longer. I've known some people go to F40 with C14s on the moon. You're not looking at a whole lot of the moon through your camera viewfinder at F40, but that's how you'll get the 0.3 arc second image features on the moon. And that's what you'll get with a 14-inch. Next, please. That's what I just discussed. And if you're going to be worrying about getting the finest detail, you're going to want to filter red to limit out haze, dust, smoke. We get bad fires out here in the West. And so smoke becomes a problem. In fact, my friend up in Payson, Arizona, Chris Scher, some of you might have seen some of his deep sky images on Facebook. Chris Scher has fires every summer, horrible fires. And he doesn't even have to use filters on the sun late in the day because he'll have so much smoke. He'll be able to photograph the sun directly. It's terrible. Use short exposures or a fast frame per second rate, because that's going to ensure that you trap the best seeing too. And high gain, you're going to be using that. You'll learn that as you use the camera and you get familiar with it. Next. Again, the freeware, only used from reliable sites. I list a few of the sites here, CNET, 2 Cows. I don't know if 2 Cows is still around. SourceForge is, and Softonic. And I download software from SourceForge. But again, you got to be careful you're clicking on the download button you want, because they try to get you to download a lot of other stuff that has nothing to do with what you're looking for. You always got to be watchful. And be careful as software downloads and installs, and cancel if you think you got something suspicious. Don't be afraid to cancel it. Broken software is better than bad software. Next. For taking images with webcams, I like the proprietary software supplied with the camera. I use the ICAP software that Celestron provided. A lot of people like to use other software. There's Software Bisque, Astro Toaster, IC Capture. I forget all the different softwares. I've got a lot of it on my computer. Fire Capture is really popular. Even today, it's been popular for a long time. Next. Now this shows a raw image when you get it. Take a picture. Yeah, this is Clavius, and this is taken with my 8-inch on a mediocre night. It's not a great night, but it's an average night. I get typically arc-second seeing here, but I don't usually get better than that. Next. So for reducing the images, you got to stack them. And I usually don't bother with more than 500. 500 in a stack, and your software will usually throw out, you should tell it to throw out half of the stack. That'll be the worst images. The software will determine which are worst for movement or just from blur. And Registax is a good software to use. I prefer AVI Stack too. AstroStacker is loved by many, and some use Deep Sky Stacker. They're all good software to use. Pick one and get used to it. Some people like to do AVI Stack and then go to Registax for the wavelets control. I like the wavelet control in AVI Stack. I find that it works just fine, especially since you can determine how many wavelets you want to use in a given image. You can use from 2 to 5. No, I think you can use up to 10 now. And so I use only 5. I find that's more than enough to get me in trouble. Next. So this is after you've stacked the image and you can see that it's much clearer now. You can see smaller craters and everything, but it's still fuzzy. And the contrast is poor. It's low. It's next. Oops. Back up just one. This is after you run it through the wavelets and you start to reduce the software down so you can see more details. You can see some of the tiny craters now on the bottom of Clavius. Next. Post-processing, I like to use GIMP. I'm cheap, I admit it. I won't pay for software usually. A lot of people like Photoshop, but you have to subscribe to it now. This link is the old days. I think if you go to that link, it'll just ask you to subscribe, and they update it when it needs updating. That annoys me. Once I get used to a piece of software, I like to just leave it alone. Next, please. So this is after I've run it through GIMP. And now we're starting to see a lot of detail around Porter and the bottom of the crater there. You can see the splash marks from the impact. So you're getting into the good detail now on this. Next. So other software you can use that will be very useful. Virtual Dub is one. I like that for adding text to the I know Virtual Dub I like for selecting software. Lots of times the camera will output images that can't be read by the software, by AVI Stack or whatever. It can't be read for whatever reason. It's usually because of a single digit in the software or in the image, a digit that has to be changed. And you can run it through Virtual Dub and it will output the correct format for that. And then you're good to go. iMerge is another piece of software. I don't know if that's made anymore. You could probably find it in one of the old software websites. iMerge is good for taking two views on the moon that are next to each other, and you can slowly bring them into each other, overlap them, and then freeze it into one image. For that, I use MS ICE mostly, and it's great. It's still made by Microsoft, and it's available at Softonics, CNET, TechSpot. It's no longer supported or updated by Microsoft, but they still have it on their website. And it's very powerful. It'll take a dozen images that have overlap of various amounts, and it'll put them all together, and you'll have a large area of the moon. WinJupos is another piece of software you ought to have in your computer for not only locating things on the moon. It does pretty much what Virtual Moon Atlas does, but it also is good for the planets, for derotating Jupiter images, and for finding out what you're looking at on Mars or whatever. It's a wonderful software, not only for looking at your images, what you've got, but it's a good one to use for planning a night's observing. Next, please. So after I've used software to put the text in, and this is the final image, and put some image information there. You should put in there you're seeing. This is very average seeing I have here. And this is back when I was using more images than I do now. I found that at 500 images, it's really just a waste of time to do much more. I get just as much detail in 500 as I would with 3000. And as I say, it's an 8-inch f20. Put an accurate time on your images. That's always important, especially if you happen in the dark areas to catch a flash, which could be an impact. The lunar impact section of the ALPO is always interested in flashes you happen to catch on the moon. And as I say, you put your camera on there. This is the old SkyRays camera. I now use a 236, which has the 7 micron pixels, and any filters you use. And again, you'll see that's a red filter. Next, go ahead. That was good. Don't try to do the whole disk of the moon. It's like trying to drink from a fire hose. It's just way too much, and it's not worth all the work. Concentrate on smaller areas of interest, like I say, like the Hyginus Rill or Triesnecker or something like that. Watch for interesting circumstances like libration. The moon nods back and forth. If you look up libration, there's some beautiful work people have done where they've taken a picture of the moon every night for a couple of rotations or a couple of lunations, and you can see the moon wobbling around, and that's the libration. It allows you to see about 5% more of the surface of the moon than if it was just sitting there without moving. And these areas are very interesting all the time, and they're sought after by lunar imagers like me. And so that's something to watch for. Perigee and apogee, you very quickly, if your telescope is over 4 inches aperture, you're going to notice a difference in your images on perigee and apogee. And it gets especially sensitive for larger telescopes when you're looking at 1 kilometer and less objects on the moon. Like I said, remember, 1 kilometer, you can see down the road 1 kilometer. That's how small a crater you'll be imaging. And shadows and configurations, I got this slide cut off on the side. Like the lunar X, there's an area where there's crater walls that intersect such that when the sun is rising on them, just the tips of the mountains are lit up, and it forms a very distinct X on the moon. There's a number of other X's on the moon, and people have taken to finding all kinds of other shapes on the moon, and they're almost always seen on the terminator where the sun is rising or setting. Next. Now you can analyze your results using a lot of nice online sources like the 1 to 1 million scale maps, lunar map catalog. Digital Orbiter Photographic Atlas, and the LROC Quick Map. These things are fantastic. They weren't there 15, 20 years ago. Next. This shows the 1 to 1 million scale maps. Each one of these is a map. And you can really zoom in next on little areas. You find one area here. Here's Clavius down in the lower left of this image. And it's got an overlap of another image, so it kind of looks fuzzy. And this shows you the detail you're seeing, which is far beyond the photograph I was taking. And these are all spacecraft images. Next. And they're all identified too. This is zooming in on the Lunar Photographic Atlas there, the 1 to 1 million maps rather. And now you can see craters below 1 kilometer in size here. You're seeing craters only a couple 100 meters across here. And this is the kind of thing you can use to gauge your own images. How far down are you getting with this? How much are you seeing? Next. This is the Lunar Orbiter Photographic Atlas. Again, same kind of detail, a few 100 meters across objects. And you can see this is Clavius again. You can see the little arc of secondary craters on the bottom. Next. And there's the LROC picture. And that's taken from the Earth, not spacecraft. Well, it is taken from spacecraft, but it's projected to be an Earth view. And here you can see it. And my images compare well with this, and my best images of this compare very well with it. This is about what you could photograph with a 12-inch telescope. Next. So I urge you to go forth and be a lunatic. You're welcome to ask me about any of this stuff. I think you got most of the links already posted in the chats for this talk. And I urge you to go ahead and do some lunar imaging. Don't hesitate to contact me. Let's see if I got a slide with my email on it, the next one. I guess not. Okay, I didn't think I did. Okay, well, my email is rhill24@cox.net. And you're welcome to just contact me.
And if you'd like to see more of Rik's amazing lunar photography, just keep reading the WASP because he's featured every month.
It used to be on my website, but one of the benefits of being a retiree from Lunar Planetary Lab is they took my website away.
Oh, yes, go ahead.
What's that? What's this resolution you can get to the surface? Can you see a car or a person?
So the question is, what is the smallest resolution you can get from Earth on the moon? Can you see, for instance, a lunar rover?
No, you can't see any of the spacecraft on the moon, but LROC can. And if you search for that on the LROC's website, they show you, you can see the different Apollos and the trackways from the rovers and everything leaving the spacecraft.
Rik, we've got an echo on you again.
I didn't know if you were hearing the echo.
Oh, I think it's for me, but
Oh, okay.
Any other questions?
all right, any other questions? Yes, Laura.
I'm a camera collector and in the art room, and I've been thinking I'd like to try the old school with film. I don't know if you've had any experience with that, and you might be able to give me any advice.
Yeah, so Tom asks, he's a camera collector and is interested in maybe returning to the old ways of
Oh,
astrophotography. Do you have any advice on that? I actually have copies of our former member Larry Kalinowski's imaging guide for film, so I'll get you a copy. It just has somebody else's name on it because she plagiarized it. But
You
but
have to, you have to put your hand over your mic so we don't get the feedback.
oh,
If you put your hand over your microphone, we won't get the feedback. But
sir.
yeah, Larry Kalinowski was one of the ones that got me started in photography. So yeah, I've got a lot of that, and I've gotten rid of boxes of photographs. One thing you'll need is a good set of photographs. Any other questions?
Yeah, we have one. I'm going to mute my microphone so you're not getting feedback. So Laura's question is, have they taken pictures of the dark side of the moon like the front? Well,
Oh yes,
as a matter of fact, it's all dark, but
yeah.
but the far side of the moon isn't necessarily dark. It's only dark when
This side is bright.
it's only dark when the moon is full. So when the moon is full, the far side of the moon is dark. When the moon is new, the far side of the moon is lit up, right?
But it's still a fantastic album.
It is. It is a great album.
But yes,
But
L Rock did the far side of the moon too. It's mind boggling to see some of the features on the far side of the moon because there's less of the seas that we see, no mare like we see on this side of the moon, just a couple of smaller ones, and so it's just a plethora of craters and rills, and it's amazing. So thank you very much.
all right, let's have a round of applause. Thank you, Rick.
And it all worked this time.
Woohoo! All right.
All right, fabulous. So, that's our meeting. Jonathan, I believe you will be leading a delegation to the Redcoat Tavern. You're muted, Jonathan. You're muted.
I know, but if you're not here in person, you're not going to the Redcoat. So,
Yeah, I know.
um, although I am going to be taking some Redcoat to Diane. So,
Yay. All
all
right.
right. Thank you
Thank
so
you,
much for
everybody.
coming. Have a great night and safe travels.